Hey everybody, we're going to talk now about how to do derivatives, use the easy way, not with that horrible formula we were looking at the other day. So I want to just introduce slowly the first rules for you and then expand upon those. So I'm talking mainly, or for this video, about, I'm looking at the rules in section 3.3. And I'm going through the rules on your worksheet that I sent you. So the first rule is called the constant rule, and that rule says if you have a number by itself, then that derivative will automatically be zero. So here it is in the formal set up. So the derivative of just a number, that's what that C means, is always zero. And that's because derivatives are slopes. And so if you have the slope of, say, the line y equal 5, that's a horizontal line which has a slope of 0. So anytime you have a standalone constant, the slope is going to be 0. So for example, I'm going to try to squeeze this first example in here. If I have f of x equal 5, that's a standalone constant. So the derivative, which is represented by this f prime notation, is going to be 0. For my second example, we have g of x equal e to the third, and this is also a constant. Remember, e is approximately equal to a number to the decimal 2.71. So e to the third is a constant. There are no variables in that problem. There's no x in that problem. So for the same reason as before, the derivative is going to be 0. One of the most important rules is called the power rule, and that derivative rule says that if you have x to the nth power, where n is just a number, then you can find that derivative by bringing the power down, and x will be to the power reduced by 1. For example, if we have y equal x to the 5th power, the power rule says that the derivative y prime will be 5. See how I'm bringing the power down? X to the 5 minus 1, and I'm reducing the power by 1. So my answer is 5x to the 4th power. My second example is just f of t equal t. And so if I have just f of t equal t, then that is understood to be, sorry, I messed up here. That is understood to be just, let me erase that. So that is understood to be just t to the 1st power. Therefore, f prime of t, bring the 1 down, that's the power. Put your t down, and then 1 minus 1, we have to subtract 1 from the power. So that will give me 1 times t to the 0. And remember that that's just 1 times 1, because anything to the 0 power is 1, which means my answer is the derivative of t is just 1. In this example, we first need to get it in the proper form. So remember that if you have a root, you can write this as a power by taking the inside power as your numerator and whatever the root is as your denominator. So a square root means my denominator is going to be 2. So I have to get it in that power form first. Now, so using the power rule, the derivative then, again, remember says bring the power down. So that's 5 halves. Bring down x to the, and take 1 off the power, so 5 halves minus 1. That simplifies to 5x to the, and 5 halves minus 1 is 3 halves. Once again, I have to simplify this, so that means that I need to bring my x to the 4th up. So when I do that, remember that that changes the sign of the power. So 1 over x to the 4th is the same as x to the negative 4. Whenever you change positions, that means your exponent needs to change into a negative power. Okay, so now it's in that correct form. So again, I'm bringing my power down. So I bring my negative 4 down and change my power by taking 1 from my power. So that simplifies to negative 4x to the negative 5. Another rule we need to look at is what happens if I don't have a standalone constant, but I'm multiplying my constant by an existing function. And so this rule says that whenever you have a constant multiplied by a function, then you do keep your constant. We don't do anything with the constant. We only do the derivative of the f of x part. Okay, so for example, I have 5x to the third. Therefore, my derivative will be, let me try to squeeze it in here, will mean that I keep my constant and I apply the power rule to my x to the third part. So that means I bring my power down and I take 1 off the power, which makes my 3 become a 2. And then I simplify that by just multiplying my 5 times 3. So my answer is 15 x to the second power. This problem, g of w equal 5, 6 w to the 12th. Again, you've got a constant multiplied by a variable situation, so you keep your constant. So my derivative will be keep my constant 5, 6, and do the derivative, multiply that by the derivative of w to the 12th, which would be 12 w to the 11th. And then I just have to multiply 5, 6 times 12 to get 10 w to the 11th. I will need to rewrite this example. So first of all, rewrite this as g of t equal 6t to the 1/2, 1 coming from the interior power, and since it's a square root, my denominator would be 2. So applying the constant multiple rule, I keep my 6, I do the derivative of t to the 1/2, so that would be 1/2 t to the negative 1/2, and I multiply 6 times 1/2 is 3t to the negative 1/2. Finally, one more example. What you'll need to do here is to factor that 4 out. Since it's in the denominator, that's 1/4. And then rewrite the square root of x as x to the 1/2. And then I'm ready to take a derivative. So f prime of x would keep my constant and apply the power rule. So times 1/2 x to the negative 1/2, so that when I multiply my 1/4 times my 1/2, I get my answer 1/8 x to the negative 1/2. I hope that gives you the basics you need to do. You need to have to be able to do these more complex problems, which are coming later.